This will be about using the cosine law. In this scenario, we have a triangle labeled ABC with an angle of 58 degrees across from corner A and 32 meters across from angle B and 40 meters across from angle C. So the goal for this is going to be to determine the side length A, or if you're looking at the fully labeled triangle, the line of CB. And we're going to round this to the nearest meter. So just go ahead and draw yourself a diagram. Okay, now that you've got a diagram, you can see that angle A is up here at 58 degrees. Across is the side length that we're actually trying to figure out. So that's the side that we're going to be working with. And then we've labeled angle B, angle C with the capital letters, so the uppercase letters, and lowercase being the side lengths across from them. So what we know at this point is we've got 40 meters and 32 meters. So let's go ahead and use the equations that we're going to put to work today. It's the cosine law. If you just look at it, you can see with the cosine law on the top, there is a measurement that we're looking for on the left. It just happens to have the same letter as the example that we're looking at. It doesn't always have the same letter, but in this case, A is what we're going to be solving for. So this letter here. Again, those could be different letters. So as we look at the information given, how do we know when to use the cosine law? If you look at this equation, you can see we have 3 side lengths. 2 of them we know. 1 of them we don't. And we have an angle that we know, which is across from the side length we're looking to solve for. So in this case, we're going to use this equation right here to solve for side length A. This other one we use in a later example. So for this purpose, we're going to use this equation, and we're going to help figure out what side length A equals. So to do that, sub in all of our values. So sub 1. Step 1, we've got, excuse me, side length B being 32, C being 40, we've subbed those in, and then we check the equation. BC is being multiplied by cosine of A. So put the B value of 32 back here and 40 for C. And we're going to multiply all that by cosine of 58. Okay, so if we go and we do that in our calculators, we will get this answer, keeping in mind that has not been square rooted. We need to square root that to finish it off. So when we're done, we should get a side length of 36 meters. Okay, so we'll just go and we'll just double check that. Okay, so as we put that into our calculator, we're going to go 32 squared plus the 40 squared minus, I'm going to put everything in brackets now, 2 times 32 times 40 times cos of 58. Okay, so we get that number there, which is this number. But remember, it's not square rooted yet. So we need to square root to actually solve for the A. Right now it's A squared is that value. So we're going to go and do the square root of 1267 decimal 406684. And we get to 35.6 rounded to the nearest meters, 36 meters. Also, if you don't get that answer for some reason, check your mode. I'm in degree mode, and for this question, we should be in degree mode. So if for some reason you're stuck on radians, just go into here. So that was mode, hit to the right, hit enter, make sure it's in degrees, and then back out. Okay, so we do get that 35.6 rounded to 36 meters. Moving to the next part. Okay, so in this scenario, we're going to use the cosine law to figure out an angle. So the scenario we're given is a local building code states that the angle formed at the peak of a roof must fall within the range of 70 to 80 degrees so that the snow and ice will not build up. In our diagram, we have a support beam DE, which will run parallel to the line AB. And our idea is the angle that's up there going to pass the building code? So is it between 70 and 80 degrees? So that's kind of what we're going to be looking for to solve when we're solving this. Okay, so let's, again, get something to work with. So we have a diagram, and we've got our equations. So we know that we're not dealing with the top equation. That's for side lengths. We're going to deal with the bottom equation. That's going to be for finding angles. And in this case, the angle we're looking for is up here. Okay, so when we actually work through this, we're going to need to put our information into a formula of this form. You can put it into the original form and solve for cosine A, but this has already been solved for here with this form of the equation, so why not use that? So let's just go ahead and work that through a little bit. Okay, we'll just pop this over so we can see it. So we start with the form a squared equals to b squared plus c squared. All that from there, you're going to subtract 2bc cos A. Okay, but we don't need to worry about that form. We're going to jump right to this part where we have cosine A equals c squared plus b squared minus a squared divided by 2bc. And then we'll look at how these numbers get in there. So if we look at our diagram, C is going to be here, across from angle C. So that's 10. Keeping in mind, we want everything in 1 unit. Okay, so this is given in feet and inches. We know that 6 inches is half a foot. So we're going to say that 19 and 6 inches is 19.5 feet. So now everything here is in feet. Okay, when we're looking at side length A, that here is given as 20 feet. Okay, so we're going to put 20 feet there, and then we're going to divide by 2 times BC in this case. Again, B was 19.5 feet, and C was 10 feet. So we sub that into this equation, and then we just work it out. So let's work it out on the calculator here. Okay, so I'm going to take everything on the top, divide by everything on the bottom, and then we'll do a second function just so there's no mistakes due to brackets. Okay, so we'll just do 10 squared plus 19.5 squared minus 20 squared. So that's the top. And then we'll divide by 2 times 19.5 times 10. So we get that number there. And then we're going to go second function, cosine, to find the angle, and put that whole decimal in. And we get to 78.125 degrees. Okay, so as we can see, that does fit between 70 and 80 degrees. So yes, this plan will pass the building code. If you were interested in seeing it done the other way, we have that over here as well, where you start with the cosine law with a squared equals to the rest of the equation. You sub your values in, isolate for the angle you're looking for, and then you get to the same type of setup. Okay, so you get to the same answer. So either way you do it, yes, this will pass the building code. Moving to the next part. We're going to do a little bit of an application in terms of a visual. Okay, so the situation here is a 3-pointed star is made up of an equilateral triangle and 3 congruent isosceles triangles. It's up to us to determine the length of one side of the equilateral triangle to the nearest centimeter. So again, let's get a nice visual for this. So just take a minute, draw yourself a picture. Keep in mind we have equilateral triangle and then 3 congruent isosceles triangles around that equilateral triangle on each side. Okay, so now that you've drawn yourself a visual, here we can see there is a side length of 60, another side length of 60, and what we're going to be asked to figure out is this side length. Okay, and now we have an actual angle that we can work with, so we can figure this out. So again, you're thinking, okay, well, how do I know when to use the cosine law? Okay, well, in this case, we are looking for a side length. We have 2 measures given, and we have 1 angle given. So that's a clue. We can use the cosine law given that scenario. Okay, so we're going to go through and set up again. So here's our starting equation. A squared equals to b squared plus c squared minus 2bc times cosine of a. And then we'll just sub our values in. So we've got the 60 squared plus the 60 squared minus 2 times 60 times 60 times cos of 20. And then we just get this when it's all multiplied and added. And then square root that. And we get this 20.837. And then round to the nearest centimeter. So we get 21 centimeters. Okay, so again, just go in there and crunch those numbers. So we'll go 60 squared plus another 60 squared minus everything in brackets, 2 times 60 times 60 times cos of 20. Okay, so we get that number, which is the same as this, but again, we have to square root it. So just put that whole number in. Close our bracket and round when we're done. Okay, so we get to 21 centimeters. So the side length here, one of the side lengths of the equilateral triangle is 21 centimeters.